Okay, so we're going to learn about how to sketch a quadratic. I've just decided to scare you guys by drawing all four of them out first of all. There's not as much to it as it may initially seem. Key things to remember are you're looking for important points when you're sketching. It is a sketch after all, it is not a perfect diagram. Every quadratic has this x squared in it. Okay, that's the main defining characteristic. The other thing you're looking for is they're often in three parts, okay? And it's the equation here, 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 and here is the link between the x coordinates and the corresponding y coordinates. So how far along are you in the x-axis when you're 0 high? Or how what's the x value when you're 0 high? Things like that. As you can see, for every diagram I've actually drawn, I've marked on really important points to help me sketch it. I've marked on the roots, i.e. where it cuts the x-axis. Where appropriate, I've marked on the y-intercept, where it cuts the y-axis. And I've also marked on the turning point. And that's what we're going to be learning how to do. We're going to be learning how to sketch ax squared plus bx plus c, the three ones, with roots, turning points, and all that information. And we're going to learn how to sketch each style of graph. Okay? Okay, for the aim for this video is for us to be able to identify whether or not a parabola is a positive or a negative parabola, or has a positive gradient or negative gradient. It's quite straightforward skill and shouldn't take us too long to cover. Basically, you should know roughly what a parabola looks like. It's basically a horseshoe, I suppose is a way of describing it. In this case, I'm just going to show you if there's nothing attached to the parabola, y equals ax squared. So it's just this term, the x squared term on its own. We know that the turning point is at the origin and the y-intercept's at the origin. We also know that it's going to look something like this. Key points to take out of that: it's symmetrical. Parabola should be always symmetrical, or as close to you as you can to being symmetrical in your sketches. And if it's a positive value in front of the x squared, it's a positive parabola, it's going to go down and then up in a smiley face. So the x squared coefficient tells us whether or not it's going to be positive, smiley face in this case, or in this case it's going to be a negative. It's going to be a sad face, right? It goes and looks like this. Right, and it's just going to continue on. So that's the key points. If the value in front of the x squared is positive, it's a happy face. If the value in front of the ax squared is negative, it's a sad face. Should also make very clear here that this, if it's a positive parabola, it has a minimum turning point, and if it's a negative in front of the x squared, it has a maximum turning point.